In this video, I'll show you how to solve a linear system with two unknowns by the matrix inversion method. This is question 3 in the series. The question reads, solve the following using the inversion method. This is the first time where we're dealing with fractional coefficients. Take a look. These terms all have fractions as their coefficient. Now you can choose to work with the fractions, or you can multiply the whole equation by the lowest common denominator and get rid of them. I'll choose to do that. So 3 and 2, a common denominator is 6. So I'll multiply this by 6, and I'll multiply this by 6. If you do that, you end up with 2x plus 3y is equal to 6. And for the bottom one, you end up with 3x minus 2y is equal to negative 6. Now we can start with step 1, which says set up the equation in standard form. It's already in standard form. The terms are all on one side and the constants are on the other. Step number 2 is to create A as the coefficient matrix. So A is equal to 2, 3, 3, and negative 2. Step 3 is to find A inverse by either transformation or the shortcut method. I choose the shortcut method. We start off by finding the determinant. 2 times negative 2 is negative 4, minus 3 times 3 is 9, and this gives us negative 13. That is our determinant. Next, we will switch 2 and negative 2, their positions, where this becomes negative 2 and this becomes positive 2. And in the last step, we change the symbol of the opposite diagonal. So this is positive, becomes negative, this is positive, it becomes negative. Now we divide each of these elements by negative 13. Negative 2 over negative 13 is 2 over 13. That becomes 3 over 13, 3 over 13, and lastly, negative 2 over 13. This right here represents the inverse of matrix A. Our last step is to create a column vector, which we'll call B, for the right side, which was 6 and negative 6. And what we'll do is multiply A inverse with B. Let's go ahead and do that. So I'll rewrite this. Multiplied by 6 and negative 6. We'll next use our calculator to do this. The solution should give us x and y. Opening up our calculator, 2 over 13 times 6 plus 3 over 13 times negative 6. And this gives us negative 6 over 13. Negative 6 over 13. And we'll do the same calculation, but for this row, where we have bracket 3 over 13 times 6 plus negative 2 over 13 times negative 6. And you should end up with 30 over 13. This represents your x, and this represents your y. That right there is the point of intersection, and there you have it. That is how to solve a linear system with two unknowns by the matrix inversion method.